Buenos dias. My name is Greg Mandt. I'm the program manager for the United States' next generation of geostationary weather satellites. I was here today to discuss where we are in the program. We basically have finished building the satellite, and we are getting ready to launch this October. So we are very excited at this point in starting to share the capabilities of this new satellite with the whole hemisphere of the Americas. This is the first change in the 40-year history of the geostationary satellites in terms of capability of the instruments from the start of the program in 1975. So our basic instrumentation consists of an imager, which looks at the visible, near-infrared, and infrared portion of the spectrum. And we have 16 channels compared to only 5 today. We're also making big improvements with the imager in terms of the temporal resolution. So today there's a conflict between looking at various storms, so we have to zoom in with the current satellite, and when we zoom in, we really reduce the amount of data taken over the whole hemisphere. So those users such as since Costa Rica could only see the GOES image every 3 hours. With the new imager, we'll be able to look at the entire hemisphere, all 16 channels, every 5 minutes. We can also zoom in on like a specific hurricane and look at that hurricane every 30 seconds. And when we do that, we will still look at the whole hemisphere every 15 minutes. So it's a much faster imager, giving a much more data across a wide variety of spectrum. In addition, we're doubling the resolution. So the visible channels will be at half a kilometer resolution, the near infrared at about 1 kilometer, and the far infrared at 2 kilometer. So it's a dramatically improved imager from what people are used to today. We are also introducing a new lightning mapper, which will be able to see the lightning, the total lightning. That's not only cloud to ground, which ground-based observing networks can observe, but also the cloud to cloud, which represents about 90% of all the lightning. And the research on what we can use the lightning data is very, very interesting, as people have correlated the flash density of the cloud to cloud lightning with the initiation of convection. Therefore, we can start to see the onset of, for example, tornadoes or severe weather much earlier than they can by just looking at radar signals. So with that, we're hoping to see a much longer increase in terms of the warning lead times for such things as tornadoes. And equally important, if not more so, we'll be able to reduce by about 50% the false alarm rate. A lot of people right now do not take the warning seriously because there's so many false alarms. So by cutting that in half, we expect that the societal response will be much better. In addition to these atmospheric pointing sensors, we are also including a brand new array of space weather instrumentations. So we have 3 telescopes looking at the sun, looking in the ultraviolet and the extreme ultraviolet and X-ray spectrum. That's really watching the surface of the sun, looking for coronal mass ejections and other events, sunspots, that affect the amount of energy that comes from the sun and hitting the Earth. In addition to the 3 telescopes that are looking at the sun, we've got about 5 sensors on the satellite bus that measure such things as ions, protons, electrons in the near satellite environment. And from that, we can get a measure of the quantitative measure of the particles as they're coming and hitting the Earth from the sun. We're also flying a magnetometer that is measuring the intensity of the Earth's magnetic field, which is protecting us from the harmful effects of the particles from the sun. So all of these instruments are finished and they're on the satellite, and we've been able to actually create proxy data sets of all of these products that we're going to produce from these satellites, and we've been sharing them with our forecasters to get a better understanding from them of how to use these new products in the forecasting process. And from this, I was able to show a lot of good pictures of the various new data, how it can be used for hurricane forecasting, for tornado forecasting, for severe weather, and how it affects the aviation and marine, as well as many other industries in terms of better forecasting. Japan has already launched one of these, as when we developed it, they decided to buy one as well from our vendor, and they were able to launch that as a single instrument on a satellite recently, and that data is currently available. And for researchers who are interested in using the data sets are available through JMA or from the University of Wisconsin or Colorado State University. And in my briefing, if you can get the charts, I have all the websites you can get access to that data sets. We are pulling this all together. We're going to be launching. It's a very exciting time for us. The Japanese, when they first saw this, they described the new imager as like going from an analog black and white television to start watching HD TV. So it's just when you see the data sets, it's just a phenomenal growth capability. And we're only beginning to open up possibilities of how to use these data and use them for the benefit of mankind in all different kinds of ways. The 16 channels will provide us so many opportunities to look at the weather in different ways, and it'll open a door to new research. Hopefully you can find ways to use these data sets in improving forecasts. The launch is coming up Thursday, October 13th in the evening at Cape Canaveral. It's going to be a big deal for us. The satellite data will take about 4 months to start seeing the basic data flow, and then our products at about 6 months after launch. But once we do get this launched, the satellite will be left on and it'll continue to provide data. So it's a great new age of geostationary weather satellite, and we're looking forward to seeing how we can use the data and all the great things researchers will be able to do with these new data sets as well. Thank you for your interest in GOES-R, and look forward to hearing great things from all of you. Thank you.